for any two complex numbers z1 and z2. Prove that. Real part of z1 z2 equals real part of z1 real part of z2 minus imaginary part of z1 imaginary part of z2. Now how do we go about proving this? So the person is talking about any two complex numbers in general. When the person is talking about any two complex numbers, let's take two general complex numbers. Okay, let us begin with two general complex numbers. What do we begin with? Let us assume that two complex numbers z1 z2 are, let z1 is equal to a plus ib and z2 is equal to c plus id are two complex numbers. Let's say this and this are two complex numbers. Now ABCD can be anything for now, right? ABCD can be any real number. So all complex numbers, for all complex numbers which satisfy this property, this particular result, if we can prove this result for these two complex numbers, then it will be true for any complex number, right? Since ABCD can take any values. Okay, that's what we'll be taking a look at. Let Z1 and Z2 are two complex numbers. Okay. So in this case, what I'll begin with is I'll try to find the real part of Z1, Z2, the product of Z1, Z2, that is important. So let's begin and find the product of Z1, Z2 first. So therefore, Z1, Z2 product is actually A plus IB times C plus ID. That's simple? Yes, that's pretty simple. Let's multiply them together and apply the distributive law over here. A gets multiplied with C plus ID plus IB gets multiplied with C plus ID. Okay. Then the A gets multiplied further with C, and this is I times AD plus I times BC plus this is I square times BD. Can you observe that? I times I will become I square and B times D will become this. And this I square can be simplified further. I square is simply equal to minus 1. Now this will be real part, right? This will also be real part. These are imaginary parts. Can we add up the real parts together? Yes. What we'll get is AC. This will become minus BD plus I times AD plus BC. Now I want to comment about the real part of Z1, Z2. Let's talk about real part of Z1, Z2. This particular thing implies that real part of Z1, Z2 is equal to what? This is the real part of Z1, Z2. Can you observe that, right? This is imaginary part, that is real part. This is equal to AC minus BD. Now what is interesting about this AC and BD is A, can you observe here, A is the real part of Z1, yes. C is the real part of Z2, yes. B is the imaginary part of Z1 and D is imaginary Z2. And I'll replace exactly that over there. What I'll do is I'll replace A, this is further equal to, A is equal to, as you can observe, real Z1. C is equal to real Z2 minus B is equal to imaginary Z1 and D is equal to imaginary Z2. Okay. So real part of Z1, Z2 for any two complex numbers is equal to real Z1, real Z2, okay, minus imaginary Z1, imaginary Z2, and this is true for any complex numbers, and this is what we were supposed to prove. And yes, we have proved this particular result over here, right? So for any two complex numbers, we have proved the given identity. That is the final solution for this particular question, as you can see over here, right?